All right, guys, today we are going to go through acid-base reactions. So that means we're going to wrap up the notes in the packet. And we have 3 reactions we're going to talk about: neutralization reactions, titrations, and saponification. Now, at titration, we do have a calculation that we're going to use that's on our reference charts. So we'll talk about that. And we don't have a worksheet to go with this today. We're going to be jumping into review on Monday. So you'll start to see some of these questions on Monday as we start to review for the unit assessment. All right, so starting with the neutralization reaction. Now, this particular reaction was on page 1 of our notes because this is the reaction where when an acid and a base react together, you're going to produce salt and water. And the reason they call it neutralization is because the H plus and the OH negative come together and form water. All right, so if you remember, we did mention that H2O, water, can also be written as HOH, as in hydrogen and hydroxide ions. So that's where the neutral part of neutralization comes from. The H and the OH coming from each one of those reactants. Okay, so H and OH. So this is a double replacement reaction, okay, which we have right down there. So what's going to happen is the H and the Na, those are our cations, our positive ions, they're going to switch places. So now the H will be bonded with the OH, and the Na will be bonded with the Cl. Okay, so if you remember from earlier in the year, you have that switch. So now my sodium, like I said, is going to be bonded to the Cl. This is ionic, so this is the salt. And then HOH is the same thing as H2O, so that's going to be my water. All right, so now what's really, really important for a neutralization reaction is you have to be able to identify acids, bases, and salts. You have to be able to identify those. So remember your acids from table K. Remember your bases from table L, and remember that a salt is an ionic compound. And again, please write that down to remind yourself. All right, table K, table L, and ionic compounds. So now what we're going to do here is we're going to complete a couple of these neutralization reactions. What we have to keep in mind is that we have to look up charges. Now this one was completed for us. But if I had to figure out what those products were, I would be looking up the charges of each ion. And it just so happens that H is +1, Cl is -1. Na is +1, OH is -1. So everything canceled out very, very nicely here. So let's take a look at our next example. This one, we're going to have to figure out some charges. All right, so hydrogen in a compound is +1. Sulfate, which is a polyatomic ion, is -2. Lithium from the periodic table, we looked that up, +1. Hydroxide, polyatomic ion, -1. Okay, you could always remember, if going back to the other pages, H is +1, OH is -1. So just by knowing that, you can figure out the other things. The fact that I got 2 hydrogens here means that the sulfate has to be -2. The fact that OH is -1, all right, that anion is -1, the Li's got to be +1. All right, so let's trade our cations here. So now my lithium will be bonded with the sulfate. But lithium is +1, sulfate is -2. I need 2 lithiums to cancel out the charge of a sulfate. So my salt will be Li2SO4. HOH +1 - 1, nice and easy. You can write HOH or you can write water, whichever one you'd like. Okay, so we have our acid, we have our base, I have my salt, and I have my water. All right, for number 2, again, H is +1, OH is -1. This all works out. NO3 is a polyatomic ion. That's how we get the nitrate. K is +1. So I got all +1s and -1s. So this is just a very easy switch. Okay, we're just gonna put the two things together here. So I take the H and I switch that with the K. The K will now be bonded to the NO3. So I got +1, -1, and then +1 for the H, -1 for the OH. Okay, so again, when you have to predict those products, you have to look up those charges. All right, just want to remember that. And in each one of these, just so you know what is what, I put the acid as the first formula, the first reactant. The base was the second reactant. I put the salt as the first product, and I put the water as the second product, just so you know where everything is there. Okay, so that is the acid-base reaction. The titration. The titration reaction this is actually a little bit of a process, and we're gonna be looking at a video. There is a video attached with this. So I'm just gonna put a little note here for the video. So when you see that short video attached, that is called a titration, that process, and it's using a piece of equipment called a burette. Now, the calculation that we're gonna be using has to do with concentrations and volumes of acids and bases. And what we're gonna do, the point of this is to figure out the concentration of either an acid or a base. So we have this equation, MAVA equals MBVB. The lowercase a and b represents the acid and the base, and then we have the molarity and the volume. So as you're gonna see in the video, an acid and a base are going to be added to each other, all right? And it's going to use an indicator to reach an endpoint. Okay, and you'll see in that video, if you haven't watched it already, that the endpoint is when the indicator changes color. And usually they use phenolphthalein. You'll see phenolphthalein a lot because it's a very, very easy color change to see between an acid and a base. It goes from that colorless to that bright pink. So you'll see how that works. And then what you do is you plug in the volumes of each solution needed to hit that endpoint, and you plug in the molarity of whichever one you know. So if you knew the molarity of the acid, you plug that in. And that way you'll be able to solve for the molarity of the base. All right? So in the video, you'll see everything walked through, and there's still a little bit of room here so you can put that calculation down. But just follow along with the video and you'll be able to see how that process takes place and the work that goes with it. Polyprotic, this is important. Poly meaning more than one, protic meaning proton. And as we've learned, protons are the same thing as H+. So if you have a polyprotic compound, this is an acid with more than one H+ ion. So examples of this would be sulfuric acid, which is H2SO4, phosphoric acid, which is H3PO4. And when you have this, you're going to have to write down as a coefficient the number of hydrogens you have. So if I were using sulfuric acid in a titration, I would put a 2 there. If I was using phosphoric acid, I would put a 3 on the acid side. And the reason for that is neutralization is happening with this titration. So when you add the H to the OH, you have to take into account that you have multiple H's in that formula. So it's just something you have to take into account with that. Okay, but again, watch through with the video and you'll see the way that the whole experiment takes place, how it all works, and how that calculation would be used. Finally, this is more of a memorization type question. And you'll also see this later in the year when we get to organic chemistry. So I'm just going to put a little note here. And the reason you'll see this later on in the year is because glycerol is an alcohol, which is an organic molecule. Fatty molecules, those are also organic. They're carbon-containing molecules. So you'll see this again later on. But what you need to know is that soap, the production of soap, and that's kind of like your key word here. Anytime you have a reaction that is dealing with the production of soap, it's a saponification reaction. But here's why we talk about it in acids and bases. If you were to take some type of fat molecule or an oil, so it could be, you could take vegetable oil, you could take olive oil, you could take animal fat, and react that with a very strong base. And what's going to happen is you're going to get these solid soap molecules that can be packed together, and you're going to have glycerol or an alcohol that can be rinsed or burned off. So what you need to know is basically this. Recognize this, okay? And if you have that base and soap is produced, it's saponification. You don't need to know structural formulas for fat molecules right now. You don't need to know glycerol. We're going to learn that later in the year. And you don't have to recognize what a soap molecule looks like either. So that's why I'm focusing right here. This is what you need to know. So as long as you recognize, say what reaction produces soap? Well, soap, saponification. There you go. Okay. So those are your 3 acid-base reactions. Okay. We have our neutralization. Acid plus base produces salt and water. We have titration, which is an acid plus a base added together to reach what's called the endpoint, and it's going to help you calculate an unknown concentration of either the acid or the base. And then we have our saponification, which is when we react a fatty molecule with a base and we produce soap. Okay, so that is wrapping up our acid-base topic. Coming up, we're going to be reviewing for a day or two, and then we'll have our unit assessment on acids and bases in a few days. So that'll be posted in the next upcoming days. All right, guys, any questions? Feel free to send me a message. Have a great day.